Hi there! In my last video when I made the camshaft, I made it out of silver steel so I could harden it later on. And Tony Simmons suggested that there's a product called CaseNet, and it allows you to harden or case harden mild steel. So I had a look around on the internet for this stuff and I couldn't find any anywhere. But I've come across this product which is probably very similar. It's called Beta 1 Case Hardening Powder. From EKP Supplies. So I might have a go using that at some point in time in the future. And Dave Stevens recently finished his Farm Boy, his number 822 Farm Boy, and I'll show you a brief video of it now. I must say that runs really well, and I think Dave's going to have a go at the Hoglet as well. And also I received from Alan Sills in the US, I think, a list of components on what you need to make the Kickstarter for the clutch for the Hoglet. I'm quite a way off from attempting that at the moment, but I do really appreciate that. It looks very interesting indeed. But anyway, in this video what I'm going to be doing is making the lifter block, which holds the valve guides, and it houses the camshaft, and it looks quite complicated, so it might be quite interesting. Well, this is a picture of the lifting block on a fixture, and you can see here that the holes here at various angles for the valve rods to go through, and you use this fixture to be able to machine it. So I've made the fixture as per the instructions, and the idea will be to first of all drill through here, M5 clear, and then open that up, and then I can bolt it to this fixture, and then I can do the rest of the machining. And once it's machined, the idea will be to bolt it on like that. Well, I've not got a 1/2 inch 2 flute end mill, but I've used this 13mm one, so all being well will be okay. So I've put the fixture in this collet chuck, and I've centred the collet chuck on the milling table. I've bolted the block to it, so what I can do now is start milling out some of these holes that go along the block. Okay, so I need to cut a radius out on each of these corners, and to be honest I find the drawing quite difficult to interpret. but I reckon that the table, the y-axis needs to be moved that way by 0.087 of an inch, and the x-axis moving it that way minus 0.631 of an inch. Once I've done this, obviously I need to cut right down to the bottom. I'll then move the x-axis this way to 0.631 of an inch. Okay, so I'll continue cutting and I'll do the rest off camera, including this side. Well, that's turned out okay so far, but now I think I've got a problem because I need to cut a recess in here for this cam gear to fit inside. And the problem I've got is these bolts are in the way, and even if I take the outside diameter of these heads down, I'm still not going to have enough room. So I think what I'm going to have to do is to take it off the fixture and put it in the 4-jaw chuck, and then cut that recess. Well, the 4-jaw chuck in the lathe plan didn't work out, so I've managed to get the rotary table on the milling machine. I've centred that, and then I think it's my lucky day because I've managed to centre this little vise, and I've centred around the hole I originally milled out. So that's spot on centre. So now I can start milling out this recess. Okay, so the radius needs to be 0.688, and this is a 12mm cutter which has got a radius of 0.236. So if you take 0.236 off 0.688, you get 0.452. So I've moved the x-axis, sorry, the y-axis this way by 0.452, and that's giving me the radius I'm after, by the looks of it. Well, the drawing says that the depth needs to be 0.219 of an inch, which is a funny number, but I'll do as I'm told. So just checking that the radius of the recess is correct. It looks pretty good. So now I need to put this back onto the fixture and start machining some sort of angles and drilling holes at angles. So that should be interesting. So to mill the top of the piece, I've put it in this 3-jaw chuck, 125mm chuck, and I've got an adapter plate here and attached it to the rotary table, and the angle reads at the moment, I don't know whether you can see that, 0.76, well, it's just gone 0.77, and if I measure the angle of the table, I get 0.74, so I can't get it any closer than that, but I think that'll be okay. And just as a double check, run this gauge along it. That looks pretty good. So I've tilted the table 25 degrees and I'm going to cut in 1/10 increments. Okay, so I've taken 290 thou off and I've just about got to that midpoint. Not quite on it, but I think that's good enough. So what I need to do now is to machine all this area out here. I might have to sacrifice a bit of this fixture. Once I've done that, I'm going to turn the rotary table back around so it's 25-degree angle on the other side and repeat exactly the same process. Once I've done that, I'll get back to you. Well, that seems to have worked out very well. That looks pretty good. But now we've got to the bit that requires a bit of bottle, because I've got to drill 4 holes at different angles and different distances. So to establish the position of the first hole, I've found this edge here, and then I've moved the x-axis to the left by 0.178 of an inch. And what I need to do now is to move the rotary table round by, let me see, 23 degrees. So the handle on my rotary table is 4 degrees every turn. So that's 5 full turns plus 3 degrees. Just check the actual gauge on the table, and that's 23 degrees. So with the surface not being quite flat, I'm just going to spot it with this 5mm end mill first of all. So now I'll centre drill, but I'll do that off camera and I'll get back to you once I start drilling and reaming the 1/4 hole. Well, having spent so much time on this part already, this is pretty hairy stuff. I don't like this drill, I'll swap that. Well, the good news is it looks as though it's come out in the middle. So I'll do the other 3 off camera based upon the dimensions in the drawing. The last hole. I'll ream it off camera. Well, that seems to have worked out okay. Pretty happy with that result. And what I need to do now is to make the front cover. Now, I was thinking about redesigning the front cover to be something like that, so it can take this ball bearing. However, having looked at the drawing again, I realise that the bush that goes in here extends out so that you can put a timing plate on the end of it. So if I go with what I was thinking about going with, that won't work. So I think I'm going to have to revert back to the original design. So I'll make the front cover as per the drawing. Okay, so I've drilled the 3 fixing holes in the same way that I did on the body, and now what I need to do is to drill a hole for the bearing, the bronze bearing, and that's going to be drilled and reamed to 3/8 of an inch. So I've opened it up with a 6mm drill bit, and now I've got this 23/64 drill. So that just needs reaming, but I'll do that off camera. So now I need to put it back on the rotary table and machine it in the same way that I machined the body. Okay, so to cut the curves on the side, I've got this 13mm slot drill again. I centred on the hole, then I moved the x-axis to the right by 0.631 of an inch, and I moved the y-axis 50 thou. Any closer I'm going to hit these bolts. So I'm just going to plunge cut. So I'll do the other side in a similar manner, and then I'll get back to you to cut this radius. Well, I must say I found that quite challenging, and I'm really glad I got that component out of the way, but it's turned out okay in the end. I'm a bit disappointed that I had to use this bushing here. You know, I just couldn't use that roller bearing because this holds, like I say, it holds the adjuster for the ignition, and the instructions suggest using oil-like bushing material, but I've not got any of that. I don't know where to get that from, but that's just a brass bushing, so I don't know whether that will be good enough, but it certainly turns well. Really happy with the way it turns very freely. So I'm really chuffed with it, really. So I hope some of you found the video of interest, and I hope some of you have a go at making this Hoglet along with me, and I hope to see you later.